Hello and welcome to this tutorial on geometric sequences. So we're going to be looking at finding the terms of a geometric sequence and finding the nth term or the general term of a geometric sequence. Okay. In a geometric sequence, or sometimes called a geometric progression, each term is produced by multiplying the previous term by a value. Let's have a look at an example. 3, 6, 12, 24, 48, 96. Now, you've probably seen some sequences, arithmetic sequences, things like 9, 11, 13, 15, 17. That's an arithmetic sequence because we are adding 2 each time. There is a common difference. Now, with geometric sequence, we don't add something each time, we multiply each time. And you can probably spot fairly quickly that in this case, we multiply by 2. Multiply by 2, multiply by 2. Okay? So we are multiplying the previous term by a constant value. And if we have a look at this one, key information here is that it starts with a number 3, and then every time we multiply by 2. So what we can notice is that if we take the second term there, take the 6 and divide it by 3, we're going to get the same thing as if we take the third term and divide by the second term, the fourth and divide by the third, and so on and so on. If we take any pair of consecutive, one after the other, any consecutive pair and divide them, we'll get the same thing. So like in this case, we are always getting a common multiplier there of 2. And we call that common multiplier, we call that R, the common ratio. Okay? So R is always the same in a geometric sequence. And we could write that as 3 as the first term, multiplied by 2 gives us the second term, multiplied by 2 gives us the third term, multiplied by 2 by 2 by 2, and you'll probably be able to spot that a nice way to write that would be using powers. And if we use those powers, we can find a general formula for any geometric sequence. So let's have a look. If we call the first term U1 and the common ratio R, then we get the following sequence. The first term is U1, the second term is U1 multiplied by the ratio. The third term is U1 multiplied by the ratio squared, the fourth one multiplied by the ratio cubed, the fifth multiplied by the ratio to the power 4, the sixth ratio to the power 5, and so on all the way up to n. And when we have n, well look, the term number is always, we always use 1 less than that as the power of r. Okay, so here is our general formula. The nth term of a geometric sequence, where the first term is u1 and the common ratio is r, is this. This formula here is the one we're going to be using for geometric sequences. It's really important that you understand how that works, but it does come up in your formula booklet. So if you are studying IB, you get a formula booklet, and let me see if I can show you that one. There is your formula book that you will get, and it has the nth term of arithmetic sequences, as you can see here. It also has the nth term of geometric sequences, as you can see here. And then there are series, which we will come to in later lessons. All right, back to our formula then. So, the general term, the nth term, is multiply the first term by the common ratio as many times as 1 less than the term number. Hopefully that all makes some sense. Right, let's look at an example. Let's consider the sequence 8, 12, 18, 27. 8, 12, 18, 27. Well, that doesn't have a common difference, so it is definitely a geometric sequence. Because we are multiplying by the same thing each time. But how do we prove that? Well, let's take the second term divided by the first term, 3/2, okay, or 1.5. If we take the third term divided by the second term, so we'll take this pair, we will also get 3/2. And similarly, if we take this one, if we can prove that all of those three have the same ratio when we divide them, then we can say that that is a geometric sequence. So assuming the pattern continues, consecutive terms will have a common ratio of 3/2, and therefore it's geometric with a first term of 8. So to find the general term of this, we're going to use that formula. And so there is the formula. Let's substitute in all the values we have. Well, we've got the first term, u1, and that's 8. And we've got the common ratio now. And so we can say that un equals 8 multiplied by the common ratio to the power of n minus 1. If we were asked to find the 8th term, well, we can simply substitute in the number 8 for the n. So in here, we substitute the number 8 because we're looking for the 8th term. And that would give us that there, which if you type it in your calculator, gives you the value 136.6875. Okay, let's have a look at another example. So here we go. We've got some information from a geometric sequence. I'd suggest you pause the video, have a read of this question, and try and get your head round what it's saying. Maybe even have a go at it. You might be able to succeed with this question already. So give everyone a chance to pause now, and then I'll go through it and explain. So, third term in a sequence is 36. Sixth term is 972. Well, we need to find the first term and the common ratio. Let's substitute some numbers into our general formula, our nth term. So remember that it was u1 multiplied by the ratio to the power of n minus 1. Okay, that is our general formula. So if we know that the third term is equal to 36, we also know that n minus 1 is 2. We can use that information along with the sixth term information. And there is the sixth term information. So again, substituting in there the n minus 1, the number 5. And when we divide those two ratios there, or those two terms, we end up with r cubed equals 27. So if I divide this one by this one, I get r cubed. I divide this by this, and I get 27. And that means that r cubed is 27. Therefore, r is going to be the cube root of 27. And that, I believe, is 3. So there we go. That is the common ratio. We now need to find the first term in the sequence. So let's substitute the 3 squared in there. And we get 9 times the first term equals 36. And that means the first term is 4. So it's starting to apply that formula now to work out the other parts. First term is 4, common ratio 3 in that one. And if we wanted the general term for this one, we could say it's 4 times 3 to the power of n minus 1. Okay. Another example. The fourth term in a geometric sequence is 24. Seventh term is 192. Again, we want the first term and the common ratio. Give you a chance to pause this one now, have a go at that, use the formula, plug in the values you know, and in fact, we'll then move on and explain it. So give it a go if you want to pause it, and now I'll move on. So, using the fourth term, let's substitute all the values we've got there. N minus 1 gives us the power of the ratio, and then we use the seventh term there, and then we divide those two together, Very similar to the last question, we get a ratio of 2, and then when we substitute in, we can find in the value of the first term, which is 3 in this case. And there we go. All right. One more with some tricky algebra in it. So we need to be pretty confident with how the sequence is generated here. So we have consecutive terms in a geometric sequence, consecutive one after the other, which means that I know this second term divided by the first term is the same as the third term divided by the second term. So I've got some useful information here that I can use to find k. Let's step this one through. So I know that 2k divided by k minus 1 is equal to 21 minus k. Sorry, I did miss out the 21 minus k there. And therefore, that is my common ratio. A little bit of rearranging, and I multiply both sides by k minus 1, and I multiply both sides by 2k. So I get 2k times 2k is 4k squared, and I get 21 minus k multiplied by k minus 1 gives us this side. A little bit of rearranging there, and I expand the brackets, rearrange that to get a quadratic, and I could use my graphical calculator to solve that. Probably the best way is to show you directly on the calculator. And so I'm going to go, first of all, menu, and then I want this equation here. And I find the A button, which is the button here. Then it says equation, simultaneous polynomial or solver. We want polynomial, so I'll press F2. Degree 2, because it's a squared term. And then I'm going to put in my values here for A, B, and C. So let's just check what those were. We've got 5 for A, negative 22, and positive 21. So 5 minus 22 and positive 21. 5, enter. Negative 22, enter. Positive 21, enter. And then let's solve. And there we go. We get 2 answers. We get 3, and we get 7 over 5, or 1.4. Okay, that's a very quick rundown, but you can see that knowing how the geometric sequence works, we can find that common ratio and use it to solve that problem. Okay, I think that's enough for this tutorial. Go and give some questions a try, and good luck.